Welcome after the break. Now, just before the break, we discussed the different types of rivers and what influenced the type of runoff. So we already distinguished between two, surface runoff and groundwater runoff. Groundwater runoff is when the water infiltrates, surface runoff is when the water flows in river channels. But now we're coming to our different types of rivers, and we already discussed, you've learned in grade 10 about perennial rivers. It flows all year long. On this topographical map, it's a solid blue line. And a non-perennial river that flows only during rainy season. But we're going to go into a bit more detail today. And we're going to have a look at permanent rivers, periodic rivers, and episodic rivers. And I'm even going to throw another river, and we do find one in South Africa, and that's the exotic river, but I'll get to that now. Now, a permanent river is basically a perennial river. It flows all year long. It means it's always got water inside the water channel. A very good example for a river like that is the Vaal River. Now, this is a transverse profile of a river, from the one side of the river to another side of the river, from the one bank to another bank. Now, as you can see, just follow these keys. The water table during rainy season is down there at the bottom. During, let's say, start with dry season. So as you can see, that's the bottom of the river over there. There's always water inside the river. Now, when do we experience, let's use the Vaal River for example, most of South Africa, the interior of South Africa, experience its rainfall season during the summer. So during June and July, if you go to the Vaal River, you will notice that the water level is above the bottom of the river. But during rainy season, what happens? Obviously, a lot of rain, precipitation takes place. We experience surface runoff, even infiltration. And what happens with the water level? As you can see, the water table, it rises during rainy season. So right throughout the year, from January to December, there will be water in this river bed. And that's our permanent rivers. It's very similar what you've learned in grade 10 to your perennial rivers, because it flows all year long. Now, if you look at the periodic river, very similar to your non-perennial rivers. Now, unfortunately in South Africa, because we don't receive that much rainfall, it'll be quite a dry area because of the subtropical high pressure belt, like we discussed in the previous lessons. Periodic rivers is like your non-perennial rivers. It only flows during rainy season. So if you look at your river bed, it's a transverse profile from the one side to another side of the river bed. As you can see, let's quickly look at our keys again. The water table in the dry season, look at the water table. It's below the river bed, meaning there's no water. It's actually dried up, completely dried up. But during rainy season, for instance, during summer months in South Africa, many of our rivers will have water, because what happens? The water level rises. So that's the non-perennial rivers that you've learned in grade 10 on your topographical maps. So instead of non-perennial rivers, we refer to them as periodic rivers. So during dry season, there's no water in the river bed, but during rainy season, the water level rises and there will be water. But keep in mind, what will happen during dry season again? The water table will drop and there will be no visible water in these river systems. Now, an episodic river, and unfortunately, once again, many rivers in South Africa is episodic rivers, is rivers that only flow after heavy rainfall and only for a very short period of time. Now, as you can notice, as you can see over there, during dry season, the water table is well below the riverbed. And then during rainy season, the area receives extensive amount of rain. The water level will rise. But it won't rise enough to have enough water for keep on flowing. And immediately after the storm, the water table will drop below the riverbed. So no water will be visible. Directly after the storm takes place, there will be water visible. But a couple of hours later, most of it will be infiltrated and no water will be visible. Now in South Africa, we are fortunate enough to have an extra type of river, and that's known as a exotic. Just need to get my spelling correct over here. Exotic river. Now, the longest river in the world is the Nile River. That's basically an exotic river. And fortunately enough, South Africa's also got an example of an exotic river, and that's the Orange River. So what an exotic river is, it's a river that do not receive its rainfall from the surrounding areas, but rather from a rainfall-rich area that's quite far away. For instance, if you look at the Orange River, the river channel of the Orange River usually most of the river channel is through the Northern Cape province that receives very little rainfall. But it's a permanent river that flows through a very, very dry region. And that's the reason we call it exotic, because it's actually not possible. The surrounding areas don't receive much rainfall, but the river is a permanent river. In the case of the Nile River, if you look at the course of the Nile River, most of its course, it flows through very dry regions, such as Egypt. But the source of the river, where it gets its water from, is from exotic regions, very close to the equator, where the rainfall is quite high. Now, just a summary of the different types of rivers. A permanent river, flow all year around. There's always contact with the water table. You can see the visibility of the water, it's always there. Periodic river, the visibility of the water is there, but only during rainy season. Okay, and usually dries up during the dry season. Episodic rivers hardly ever flows, but it does, and you will be able to see the water of the very heavy rainfall. But 2 hours afterwards, it will usually dry up. Now, river discharge is the amount of water that flows out of the river. The discharge is how much of the water goes out of the river. And we use a special graph to be able to see how fast this water is moving and the amount of water that is moving through this river. And this graph is known as a flow hydrograph. Now, by now you should know hydro means water, so it's a water graph. Now, it gives two sets of information. It's basically a very special graph because it combines a bar graph with a line graph. Now, the bar graph represents the precipitation, the rainfall, the amount of rainfall. The line graph shows how quick this discharge is taking place. Now, if we go back to the definition of discharge, is the amount of water flowing out of the river. We want to see how quickly the river gets rid of this water. And the bar graph represents the amount of precipitation. Now, like all graphs, it represents a vertical, there's your vertical axis, and a horizontal axis. Now, your vertical axis represents the amount of rainfall. Now, what do we measure it? In millimeters. And the term that we use to runoff is cubic meters per second, how fast it's traveling. And then horizontal axis over the time period. It might be days, it might be hours. Now obviously we discussed it over there. As you can see, there's your bar graph showing you the amount of precipitation, and there's your line graph showing you the discharge, how fast the discharge is taking place. Now let's just quickly look at the numbering, and I'm going to jump back and forth from the slide. If you look at number 1, it represents, is the line graph like I've mentioned. It shows the volume of the water. There's the amount of discharge that takes place. Now, as you can see at number 2 over here, right? As you can see, it rises. Now, if less infiltration is taking place, it means this line graph is going to be higher. If there's going to be more infiltration, it means this line graph is going to be lower. If we look at point number 3, where the line graph is decreasing once again, like I've mentioned, they just give you an example. Urban areas, what's going to happen? That line graph is going to shoot up. Because why? Urban areas are covered with tar road surfaces, are covered with concrete surfaces. Is the water going to infiltrate? No. Why? Because it's impermeable. The water can't infiltrate over these tar road surfaces. But let's say naturally vegetated areas where there's plants, what's the water going to do? It's going to infiltrate. So that line graph is not going to be that steep. Now if you look at the falling segment at number 3, when that line graph goes from up there, down there. Now in urban areas, think of CBDs, where there's a lot of tar road surfaces. What's going to happen? Immediately the water level is going to rise immediately. The discharge is going to be immediately. But the water flows very fast because it doesn't have time to infiltrate. So that line graph is going to drop immediately. Whereas with natural areas, it's going to be much slower. Why slower? Because the vegetation slows it down and the water have time to infiltrate. Now I've already mentioned number 4 to you. If you go back to 4, that represents your bar graph. The bar graph represents the amount of millimeters of rain. As you can see, highest over there, and as the precipitation gets less, the amount of rain also decreases. Now, what they tell us about the bar graph shows the amount of rainfall, precipitation, and obviously the unit that we measure rainfall is in millimeters. Now, time lag, I prefer to call it the lag time, is the time for the heaviest rainfall to fall and for the river to experience its peak flow. Now, if you look at that, how to calculate it, you just look at the time. So basically, your lag time is over here, as you can see, where the highest amount of rainfall is, and over the time period when it falls. So when is the discharge going to be on its highest? Obviously with the most precipitation. And then when is the discharge going to be highest? Obviously where it can't really, when the line graph goes up, when the water can't infiltrate. Now if you continue looking at it, the base flow is obviously the groundwater contribution. We discussed it at the previous point. It's the water that infiltrates that will eventually lead to the discharge of river. Now keep in mind, there's 2 ways the river discharge of its water. On top of the surface and below the surface. When it infiltrates and eventually leads back, that's base flow, or when it flows on top of the river in the river channel. Now the highest point in the line graph is the peak flow discharge. Now this is where the river receives its highest amount of volume of water. Now just quickly, the differences between urban settlements and areas that's covered with natural vegetation. Now for instance, if the slope is very steep, like I've mentioned, for instance urban areas, the water won't be able to infiltrate. So the lag time is going to be very high. If the slope is gentle, there's going to be more infiltration, and we will see now in our next diagram. Now, for instance, your lag time will be different when it rains and there's discharge at the peak flow. Short lag time, more surface runoff. Longer lag time, there's more infiltration. Now I'm quickly going to show you this graph over here. As you can see, there's a natural catchment area. Now keep in mind, it started to rain. Now with natural areas, what happens? There's going to be build-up and discharge, but most of the water is going to infiltrate because of the vegetation cover and maybe because of gentle gradients. It's not as steep. Whereas you go to urban areas, urban catchment areas, because of the tar road surfaces, what's going to happen? Discharge is going to be on top of the surface. It's going to be surface runoff because there's not going to be much infiltration. But immediately, because the water volume, the discharge is happening quicker because there's no infiltration, the lag time will be much shorter, as you can see over there. But in the natural catchment areas where there's lots of vegetation, it's going to be much longer, and eventually base flow takes place over a longer time. I'll continue right after the break.